The contaminant is fixed in the solid surface. And this is the reason of why we decide to use absorbent material. And the most common one is activated carbon, but we have decided to use materials more natural like clays.
So, it's time to think about the future. Consumerism, urbanization, emerging contaminants, the industry that continues to evolve and transform matter. We need to find new absorbent materials able to be more effective and more sustainable. We decided to synthesize saponite, a phyllosilicate belonging to the class of smectites. This is a material with a very high absorption surface that allows a good recovery of the pollutant in its layer. We use as molecule of pollutants the rhodamine B because it's an hydrocarbon and it's very colorful, as you know. And his coloridinator gives us the possibility to know the concentration with a simple UV visible spectroscopy. As you can see here, there's the saponite synthesis procedure. We decide to synthesize two types of materials according to the amount of water used by the synthesis. The name of saponite is related to the ratio of water and solution present inside the clay. So for example, saponite 110 means that we have 110 grams of water per grams of solution. Since powder are very difficult to be used in the real system, we decide to create pellets. So we mix our materials with methylcellulose and water to create the pellet with the help of an hydraulic press. For the contact, we use the powder and the pellet materials, and a definite volume of rhodamine B solution was placed in contact with the material for a time of 24 hours. After the contact, the material were recovered. During the contact, an attenuation of the rosy color of the solution was observed. This fact constitutes a visual confirmation of the absorption by the materials. We carry out contact tests with saponite 110, saponite 20, and bentonite, a commercial clay to compare. A simple UV visible spectroscopy was used to know the concentration after the contact and compared to the initial concentration of the rhodamine B to calculate the absorption capacity of the materials. During the preliminary test, the pellets of saponite 110 was found the best material with the best performance, with the 82% of rhodamine B solution absorbed. So we decided to test it in a more specific way, closer to reality. So we tested it in three types of water, like deionized, fresh, and seawater, to see the behavior of the ions present in the water if they change the capacity of the saponite. The application with this type of water is very promising because our materials absorb over the 96% in each type of water and as pellet and as powder.
So, as you can see, we have found many advantages for these materials because they derive from natural resources, they are very easy to synthesize, they have a low cost of production, and we can recover them by thermal process. And the only disadvantage that we have found is that they have a high time of contact. So these results show our compatibility with the use in industries for water waste treatment. And in conclusion, we think that saponites may be more suitable for the removal of certain contaminants instead of other absorbent materials. So if you want to know more about this project or if you have more questions, you can contact the professor or our school or us. So thank you for your attention.